Let's look at this example. The Chamber of Commerce of a mid-sized city has supported a proposal to change the zoning laws for a new part of town. The new regulations would allow for mixed commercial and residential use. The Chamber of Commerce would like to see if they are likely to have a majority vote. They commissioned a survey of 516 people selected at random, and 289 said they would support the measure. Find the 99% confidence interval estimate for the proportion of voters that will support the measure. So what are we given for this question? Let's have a quick look. So this is the population of people that are going to vote, and they took a sample of n equals 516 people, 516 people, and they found x, the number of people that actually will vote in favor of the measure, is going to be 289. So your sample proportion of people, p bar, that will vote in favor of the measure will be 289 out of 516. This is the sample proportion of people that will vote in favor of the measure, and that equals 0.56. So of their sample, 56% will vote for the measure. So they want us to find a 99% confidence interval, which means alpha equals 1%. And this is clearly a proportions question, yeah, because we're dealing with proportions, the proportion or the percentage of people that will vote in favor. We want to find the proportion of voters that will support the measure that's proposed. So for proportions questions, again, it's the same routine that we kind of go through. But before we can actually do the calculations and use the normal distribution and all that stuff, we have to check for proportions that n times p, or in this case we don't have p, so we're going to use p bar, is greater than or equal to 5. And also, second condition, n times 1 minus p bar is also greater than or equal to 5. If these two conditions hold, then we can go ahead. So n is the sample size, is 516, and the sample proportion is 0.56. Got it from up here, or 289 over 516, so we can just put 0.56. And that's going to give us a value of 289. 289. And of course that is greater than or equal to 5. So that first condition is met. How about the second one? So they both must be met. So n is, again, we said n is 516 times 1 minus p. So it's going to be times 1 minus 0.56, and 1 minus 0.56 is 0.44, so it's 0.4 times 516, and what does that come to? That comes to 277, and again 277 is definitely greater than or equal to 5, so that means the second condition is satisfied, so we can move ahead. So again, it's going to be the point estimate, this is for the lower limit, point estimate minus the margin of error, and the upper limit is going to be the point estimate plus the margin of error. So this is the generic formula for all confidence intervals that you're going to come across. In our particular case, the point estimate is going to be p bar. So p bar, so we want to find out the proportion of people. This is the guy we want to find out here. What's the proportion of people from the population that will vote in favor of the measure? But we only have a sample. So this sample here is our estimate, is an estimate of the population proportion. So it's going to be our point estimate is p bar, which is 0.56, minus the critical value times the standard error. Now the critical value for this type of distribution, because we've done this check, it means it's a normal distribution. So we're just going to use z of alpha over 2 for the critical value. and we're going to multiply that by the standard error. But the standard error for proportions is that formula, which is P bar times 1 minus P bar over the sample size. That's the lower limit. And remember, the margin of error is actually made up of the critical value times the standard error. And that's what we did to get down to here. That's this guy here is the critical value, and this guy here is the standard error. This is the lower limit. The upper limit is going to be the same thing with a plus sign in it. So again, it's going to be P bar plus Z of alpha over 2 times the square root of that P bar times 1 minus P bar over N. So P bar is going to be 0.56. So this is 0.56. The sample size N is 516. So the thing that we have to calculate is, again, is that Z of alpha over 2. So alpha we know is 1%. So we want to calculate Z of alpha over 2. And that's going to equal Z of not 1%, but 1% over 2, which is going to be half of 1%. So I put half of 1% like that. And what's that going to be? Well, it's going to be a norm.s.inverse. So it's going to be norm.s.inverse. But what's the actual value we're going to put in here as the probability? Well, let's just do a quick sketch of this. So Z of 0.5%. So I want to find this value here, the critical value, and this area in here is 0.5%. Excel wants the area to the left of that point. So the area to the left of that point is going to be 0.995. If it's 0.5% to the right, it's 99.5% to the left. And we can just pop over to Excel to put that into Excel. Let's see what that's going to come to. Okay, so let's go here. So we need norm.s.inverse, so equals norm.s.inverse. Where is that? Norm.s.inverse is right there. And the probability we're going to put in is 0.995. And that's going to give us a value of 2.5758293. So if we go back, we can just put the values in. Now, unfortunately, we can't use confidence.norm for this. Confidence.norm will not give us this margin of error part. It only works for the example for means, but not for proportions. So P bar, as we said, is going to be, so coming down, so let's just go straight through here. So P bar is 0.56, 0.56 minus Z of alpha over 2, and let's take Z of alpha over P over 2 to be, let's just round it right for now to 2.58. It was the figure we just worked out in Excel, and that's that one in there. And then we have to multiply that by the square root of P, which is 0.56 times 1 minus 0.56, just extend that out a little bit, and we'll divide that by the sample size, and we said that the sample size is 516. So this gives us the lower limit, and then the upper limit is going to be 0.56. Same thing except with a plus sign. Hope I have enough space to put it in here. Plus 2.58 multiplied by, I'll just put 0.56 times 1 minus 0.56. Oops. And then we can divide that out by 516. So you can put that information into Excel and you can complete the question, or you can try and do it on a calculator. I don't think I would really want to do this on a calculator, but let's see if we can put it into Excel. So we already have that figure in there, and that figure in there, 2.578 is going to be the critical value, and the sample proportion, I'm going to call it P bar, and P bar for this question we worked out to be 0.56, and the sample size N, what was that? The sample size N was 516. So we can just plug away to find the lower and upper limit. So let's remember the lower limit, so put the lower limit in here, and what's it going to equal? It's going to equal P bar minus Z of alpha over 2, which is your critical value, times, and then we can just do SQRT, the square root of, and it's going to be P bar, which is going to be that guy, multiplied by 1 minus P bar, and then we're going to divide that out by the sample size, and we're going to close our parentheses and see what answer that gives us. Gives us an answer of 0.5, about 50%. And we can do the same thing to get the upper limit, except change that sign in here to a plus sign. So what I'm going to do is I'm going to copy that, and I'm going to paste it into there, and then I just copied the same formula over. I'm just going to change that plus, that minus to a plus, and we're getting in here around 61%. So our answer is, should we look to 2 decimal places? Should we express it as a percentage? You have to read the question to see. Let's express it as a percentage, and we can change the decimal places, and 1 decimal place, 2 decimal places, no decimal places. So basically we're saying that our 99% confidence interval suggests that between 50 and 62% of the people will vote in favor of the measure. So between 50 and 62%. So let's just go back to Word, and that's saying between 50% through 62% of the people are expected to vote for the new measure, that the true population proportion of people that will vote is expected to be between 50 and 62% of the people voting in favor, and we say that with 99% confidence.